Now we are going to learn other important measures for epidemiology or in biostatistics, which are odds and odds ratio or OR. These are widely used in biostatistics and epidemiology. So odds nothing but alternative method of to express uncertainty. So we know the uncertainty can be expressed by probability. So we can through odd express the uncertainty. So what is meaning odds? Odds nothing but events occur over event does not occur. Something will happen, something will not happen. Somebody will ill, and somebody divided by somebody will not be ill. Or somebody will suffer from a specific disease over somebody will not suffer from the specific disease. So odd can be represented as a ratio, the likelihood or probability that event will occur if denoted by P over the likelihood or probability that the event will not occur. That is P on over 1 minus P. That is what is the probability that some event will occur, and we know not occur from the complement law or minus P. So if something happen, probability is P divided by 1 minus P, we will get the odds of that event. For example, if the chance of occurrence of an event X is 1 out of 10 trials, okay, some events X will occur out of 10 trials, then what is the odds of X occurring X? We can get what? The occurrence divided by does not occur. So what is the chance of occur? We know 1 out of 10, and what is the chance of not occurring? 9, 10 minus 1. So odds for that events occurrences on to 9. That is mean X will occur once for every 9 times that X will not occur. That is the chance of occurrence for the X is 1 over 9 that X will not occur. Let us do other example. We know the 6-sided dice. There are 6 sides, 1, 2, 3, 4, 5. So what is the odds of getting 5? So we know from the odds, the probability that will happen, 1 minus that will not happen, or that. So we can get the odds, number of times of getting 5. We know if we draw a single dice, there are 1 chance we may get, or we might get 5. And what is the chance we will not get? 6 minus 1, 5 times we will not get 5. So odds of getting 5 1 over 5. Or simple, if you want to can express probability of getting 5 we know 1 over 6, and probability of not getting 5 1 minus P, that will be 5 over 6. So odds will be if you divide by probability, you will get 1 over 5, 1 to 5, or simply 20% chance. That is 20% times we'll get 5s, and 80% times will not get, 20% time will get 5, and 80% time will not get 5. So this is the odd. So we have 1 chance getting 5 and 5 chance not getting 5 out of 6 outcomes, that is in a single dice. So this is the odd. Something happen, and what is the probability? Something will not happen. So odds from 0 to 1. So from the odds, you can find also probability. Okay, so we know the odds equal to P, probability minus 1 minus P. So if you do simplification, we'll get probability equal to odds divided by 1 plus odds. So let us say the odds of happening diabetes, or somebody will get the diabetes, is 1 over 19. That is 1 to 19. So what is the probability getting diabetes? So simply put, we know the probability. So odds 1 over 19 plus 1 over 19 will get it 0.05 or 5%. So there is 5% chance of developing diabetes. So from the odds, we also get the probability. Okay. So now there is other important measure that is called odds ratio, which are widely used in biostatistics and epidemiology. Odds ratio are very helpful for making decision in clinical intervention or drawing the conclusion. Okay, we'll do some example. So what is the odd ratio? Odd ratio measure the ratio of the odds of an event will occur to the odds of the event will not occur. So this is nothing but the ratio of that odds of the event will occur over the events of that do not occur. So this is the odds. So in other way, you can say odd ratio is a measure of associations to compare the odds of a disease of those who are at risk, that those who expose to the odds of the disease, those unexposed, not at risk. So this is the associations which compare the odds of disease who are exposed, who are at risk, to the odds of the disease who are not at risk. So this is other type of ratio. As for example, in clinical trial, researchers measure the ratio of the odds of a disease occurring from a specific injury or illness. What we can, the researcher interested to measure the ratio of the odds of disease from a specific injury or illness to the odds of disease not occurring from a specific injury or illness. So in this way, we can use odd ratio in clinical trial. So let us see. Also in clinical trial, researchers are interested to estimate the reduction in illness or disease complication if patient receive a particular drug or vaccine. So we can use odd ratio to estimate the reduction in disease or disease complication if patient receive a particular drug or vaccine. So how we can interpret the odd ratio? If odd ratio greater than 1 indicate increase the occurrence of the event. So if odd ratio is greater than 1, that is the chance of the occurrence of the event is more. If the odd ratio less than 1, that is decrease the occurrence of the event. That is the event have the less chance to occurrence. And if odd ratio equal to 1, that is the no difference between the groups. That is there is no association between the suggested exposure and non-exposure. As for example, we can comparing an existing treatment to a new treatment. We may compare the odds of experiencing bad outcomes if a patient take the new treatment to the odds of experiencing bad outcomes if a patient take the existing treatment. So if somebody took the new treatment, how can we find, or we can find out the odds that getting the bad outcomes if some patient take the instead of new treatment. Okay, we have an example. The odd ratio will be more clear from the example. Okay, as we told, we can use in the clinical trial. So in a study, there are 200 people, of which 100 were given the existing treatment and remaining 100 were given the new treatment. So okay, this is a clinical trial. So in 100 people, they gave the existing treatment, and other 100 people, they give the new treatment. Okay. And suppose the probability of getting a better outcome is 0.02 if the patient take the existing treatment. For the existing treatment, 20% chance of getting the bad outcome, some unexpected outcome is 20%. So it will be 20, the patient will be 20%, and bad outcome 20%, and do not have better outcome will be 80%. Okay. And in the case of new treatment, the bad outcome reduced to 0.1, 10%. So for the 100 patient, 9% experience the better outcome, some unexpected outcomes, and 90% patient do not have the bad outcomes. Okay, this is the contingency table. So for the existing treatment, this is the bad outcome and do not bad outcomes, and for the new treatment, bad outcome and do not bad outcome. This is the contingency table. From here, what is the bad outcomes? Then the odds of the bad outcome in the existing treatment will be 20/80. So odds of bad outcome for the existing treatment for the current treatment will be 20/80.025. And similarly for the odds of the new treatment for the bad outcome will be 10/19. So it will be 10/19.011. So what is the odd ratio comparing the new treatment to the old treatment? Okay, old means the existing treatment. So what is the odds outcome for the odd ratio comparing to the new treatment to the old treatment or existing treatment? So we know that for the odds of the new treatment 0.11, that is 0.111, and we know the odds of the existing treatment or the old treatment is 0.25. So odd ratio will be 0.444. That is the odd ratio of the new treatment comparing to the old treatment will be 0.444, which is for bad outcome. So this means the ratio of the bad outcome if the patient take the new treatments are reduced to 0.044, or bad outcome if the patient take the existing treatment. So common will be that we can conclude those who take the new treatments were 0.4 times less likely to have the bad outcome compared to those who take the new treatment, compared to those who take the, it will be in the old treatment. Sorry, it will be old treatment. So somebody if took the new treatment, they have the less chance they have the less chance to happen bad outcome. So in this way we can use the odd ratio. First of all, you have to find the odds. Then we can, for the two group, one is for the new treatment, other for the old treatment or existing treatment. Then we can compare the chance of the outcome. Here outcome is the bad treatment. So if somebody took the new treatment, they have less chance, 0.44 times least likely to have a bad outcome those who take the existing treatment. So this is the way we can do. There is a table. You can use the odd ratio, odd of disease in exposed, the group in risk divided by odds of disease in the non-exposed or unexposed group. That is who have not at risk. Okay, so we can do for the case control group like this odd ratio for the odd ratio of exposed. Or first of all, you have to find the odd of exposed for the case case group, and then you have to find the odd of exposed for the control group. Then you can find the odd ratio of exposed, that somebody can have the chance of developing disease for the case and control group. Okay, then you can find the odd ratio. Okay, and we know that if odd is 1, there is no difference between the two groups, that there will be no association between the exposure and the outcome group. Okay, so if odd is greater than 1, the odds of exposure are positively associated, that is more chance for the adverse outcome compared to the odds of not being unexposed group. If odd is less than 1, that odds of exposure are negatively associated with the adverse outcome, unexpected outcome, compared to the odds of not being unexposed group. So we can use the odd ratio for the case control group who have risks and who have less risks, unexposed group. So this is the all for odd and odd ratio. You need to do more practice. I'll give you more example, more exercise.